Hello, ladies and gentlemen. I decided I'd make you a recording of your solutions here for this worksheet. Since I am not here with you this morning, I am in the building. Just had a meeting that I needed to attend. So let's start with number 1 here. Okay, so if I am going to, let me see if I can zoom this in here. Let's see. All right, if we're going to look at number 1, I hope you can see that we do substitution. Okay, I will tell you your answer there is 5/8. Okay, number 2, again, you should do substitution. You're going to let y be 7x, and your final answer should be 7/9. Number 3, let's go ahead and let your y be 5x squared, and your final answer should be 5. Number 4, I believe we did in class. Number 5, I also believe we did in class. Number 6, you should let your y be 8x, and then your final answer is 0. And then number 7, we did do in class. Okay, so let's take a look at your notes then for today. First thing I want to do is give you another identity. I need for you to realize that the limit as x approaches 0 of e to the x minus 1 over x is 1. Okay, so please add that to your sheet. You will notice that today we are going to define these functions to make them continuous. So as of right now, if you take a look at number 1, this thing is not continuous. Okay, I cannot plug in 0 because of a denominator error. Now you will notice that this is not the same identity because you can see here that I have a negative symbol in there. Okay, so what we're going to do is we're going to have to do some substitution. We will say let's let y be negative x. So then the limit as x approaches 0 of negative x is still 0. Now I have the limit as y approaches 0 of e to the y minus x. Whoops, e to the y minus x. Excuse me, e to the y minus 1. Now notice here that my substitution is a negative x, and I need to plug in for a positive x. So I need to go ahead and isolate this x by dividing that negative 1 over. So I have negative y is equal to x. So down here, I'm going to have to plug in a negative y. Okay, so now you'll notice that this is my identity. You'll notice I have the negative symbol at the bottom, which means my limit will be negative 1, which means if I want to make this continuous, I have to fill in the hole. Okay, so that means I'm going to make this piecewise function where my original function is all fine when x is not 0. But when x is 0, I need to make it negative 1 to fill in the hole. Okay, let's remember how to make the equation of a line. Okay, find the equation of a line L tangent to the graph at the given point. Okay, so if I want to make an equation, I need to have a slope, and then I'll find a y-intercept. Now remember, slope is rate of change. Rate of change is a limit. So I am going to be finding a limit as x approaches 0 of f of x minus f of a all over x minus a. Now, of course, I don't need that 0 down here. So I just have that. And you'll notice that that is my identity. This thing is 0. Okay, so 0 is my slope. If 0 is my slope, this is my x, this is my y, this is my m. I'm going to plug everything in. Y equals mx plus b. Looks like my b is 1. So the equation of this tangent line will be y equals 1. That is a horizontal line. Okay, let's try another one. Oh, I thought I was going to try another one with you. Let's see here. Here we go. Let's try this guy. So I'm going to go ahead and find my slope, which means I'm going to set up a limit as x approaches 1 of f of x minus f of a all over x minus a. And of course you agree I can't plug in 1 as it stands, so I think I'm going to go ahead and multiply by a conjugate to see if I can make that work. So in the numerator, I have this. My denominator looks like that. Up top, that will be negative x squared plus 1. Bottom, I have this big old thing. I can take out a negative, and then I can factor by perfect squares in the numerator, which you will see is going to end up canceling with my denominator. And now I should be ready to go ahead and plug in a 1. If I plug in a 1 in the numerator, that's going to be a 1 plus 1, and then I have that negative sign out front. So that's going to be a negative 2. If I look at my denominator, if I put a 1 in there, that's going to be 4 minus 1, which is 3. So that's radical 3 plus radical 3, which is 2 radical 3. These will cancel. I will rationalize that and get negative radical 3 over 3. This is my slope. This is my x. This is my y. I'm now ready to plug it in to find my b. I'm going to have to add this over. So if I add radical 3 over 3, I'm going to have to get a common denominator, and the common denominator is going to be 3. So that'll be 3 radical 3 plus radical 3 all over 3, which gives me 4 radical 3 over 3, and that is my b. So my final equation of the tangent line here will be y equals negative radical 3 over 3x plus 4 radical 3 over 3. That is the equation of the tangent line. Okay, so for your homework, before your test, okay, I'm going to go back to this slide, and this is the homework over these types of problems. Now, of course, you have a test tomorrow, so this will not be checked in, but this is practice for if you need it. Okay, those 6 problems can be found on Classroom. In your classwork tab. So if we come down here, this is going to be lessons 2.4 and 2.5 homework. And we'll open this up. And if you take a look, you have those 3 problems and these 3 problems. Okay. So you have those as practice if you would like them. And I will go ahead and include the key of that on Classroom so you can see that. Tomorrow will be your test. I would suggest that you use the remainder of this time to do your reviews. Those reviews do have keys posted. Of course, I will be here in the morning if you have any questions. I will also be here after school today and during A and B for questions. My meeting this morning only goes until about 11 o'clock. So let me know if you need to see anything. Thank you.